Now we can see other question. A particle of mass is released from a point. What's the release mean? There isn't any velocity at a point, okay? They can say at rest, they can say there isn't any velocity, and here it is released. It means there isn't any velocity, okay? Frictionless, I love this part. Okay, determine the particle's speed at point B and C. Can I use total energy is conserved? Can I use this way? Yes, of course. You can use that one. It means potential energy at initial state and again kinetic energy at initial state. Yes, I am writing. I didn't include friction one because it's a frictionless system. Okay, just look at here. Velocity is 0, so I can say kinetic energy is 0. What's my potential energy? H is 5. You know, you need to use mgh. What's my m? Just I will write the formula and then we can conclude it. Oops, sorry. mg h cha equal mg hb. Just I will check first. I will find velocity. This velocity vb square. You can cancel v parts because it has all formula has m. You can cancel all of them. G is 10. H a is 5. Oop. So this one is HA. Multiply 5. 10. What's the HB? This part. Multiply 3.2 plus 1 over VB. What's the VB? VB is, what's VB? I don't know. I solved this question before you. Where is it? VB is 6 meters square. Okay, and subspace. Let's come here. If you look at C, what's the C? Again, you can think I start from here to here. That's the easy part. Because there isn't any kinetic energy at first point, so you can say just here. You can say here. I have just potential energy. It's here. This potential energy converts kinetic energy and potential energy. And then it comes here. Most energy convert to kinetic energy because I lost my elevation. I mean edge part. So here at C point, velocity must be higher. Okay, just do again. Five to again 5 to 10. I know H. What's my kilogram? Kilogram is 5 kilogram again. Sorry. It's equal to C part. 5 kilogram, 10, and just I am writing its potential energy, which is 2 plus m 1 over 2. M is 5 and VC square. This is kinetic energy. Say I will call with K. This part potential energy for C. This one is potential energy for C. Why I don't take from B to C? because there isn't any friction and you don't lose energy. So even you can take from here to that part. Okay, to C. Finally, if you calculate this part, VC will be what was it? 7.7 ms. Okay, that's easy, I think, for you. Please look at this question. It's quite similar. So please solve at home. Please solve it. Okay, I will turn back to that question. Look at here. Okay. A light rigid rod. Yani şöyle bir kablo varmış. Like this one is 77 centimeter long. This top end is pivoted on low friction horizontal axle. Okay, I will explain in Turkish. You can read that part. Şöyle bir çubuk var diyor. Daha doğrusu şöyle bir çubuk var ve çubuk şöyle bir kabloya bağlı ve kablonun ucunda da bir top var diyor. Sonra diyor ki what's minimum speed at bottom is required to make the ball go over the top of circle. Yani bu gelecek, sonra dönecek, buraya gelecek diyor. Okay. Okay. It's saying minimum speed, but again, can I use energy conservation? Of course, I can use it. Look at here. When it comes from to here, my velocity will be like that. Even you can minimum at top here. Okay, yes. If your speed at bottom is minimum, when it comes here, the final velocity will be 0. Okay. Maybe I need to explain again. I start from here with minimum energy, and then my kinetic energy, all my kinetic energy convert to potential energy, because it's saying minimum energy. Sorry, minimum velocity. It means, please come here, a key initial state, because my kinetic energy at initial state is minimum. So, and then you convert all energy to potential energy. Did you understand this part? Maybe I can explain in Turkish. Şimdi zaten diyorum hani diyor ki minimum enerjiyle hareket etsin. O zaman o kadar az enerjim olsun ki ancak yukarı çıkabileyim. Yani ancak yukarı çıkayım ve ondan sonra işte tekrar oradan hani düşer. Ya da işte orada kalır. Neyse. O kadarlık bir enerjiye ihtiyacım var. O zaman bütün enerjim neye yukarıya döndüğünde dönüşecektir? Potansiyel enerji. Okay. I will have minimum velocity with minimum kinetic energy. With this velocity, I will go up. It means you convert all kinetic energy at initial state to potential energy at final state. Did you understand this part? I hope you understand that part. So, and then it is easy part. At first point, this is initial part. There isn't any elevation, so you don't have any potential. Even you can see course, we always use that equation. Fine. Okay, nice. Initial must equal to final one. But its first point isn't any potential energy, so your potential energy will be 0. Just you will have kinetic energy. So, and then to minimum, your kinetic energy, say K, must be 0, and then your kinetic energy is converted to potential energy. Just 0, 0, you can cancel M, and you can write V square 2H, 2GH. Just you need to write 10. What's the H? Okay, what's the H? What do you think? If this part is L, it comes to here. This part must be L, okay? Because this road is L. So H will be 2L. I know L is 77. So please be careful. It says centimeter. You need to convert this centimeter to meter. Okay. So it means 0.70 blah blah meter. I think you can find easily this part. Just you need to put all math here and your initial velocity. Just I want to write here. Your initial velocity will be what was it? 5.45 ms. Okay. If you don't understand that question, please ask me. Maybe I can make one more question here. Okay. Finally, we have some coefficients. I love coefficients. Between 2 kilogram block and the surface is that fun, and nu k is 0.4. The systems start from rest. It means kinetic energy at initial part will be 0 because velocity is 0. This part will be 0 for kinetic. I am talking about kinetic energy. How can I write total energy? Okay, I use same thing. Total energy is initial state. It must be equal to total energy at final state. I always saying same thing. Kinetic energy at initial state and potential energy at initial state. Should I apply to force work done by force to initial state? What do you think? No, because at first part, this mass is not meet with friction. Why I should add here? No, I have to add the second part, which is initial part. So final part. So can I write like that? Final plus final, and then work by friction. Please be careful. You always add this work for friction to at second part. I mean at final state, because now after some point this mass is met by friction. Yani bununla ne zaman temas edecek? Tabii ki sonradan edecek yani. Onun için sonraya, yani final kısmına gidiyoruz, tamam mı arkadaşlar? Okay. Kinetic energy is 0. I know. What is potential energy? Should I care this mass of potential? Is there any potential energy of this 2 kilogram mass? No, there isn't any elevation here. I shouldn't care this one, but should I care this one? Say there is H. Okay. Say H. Yes, I have to care that one. 5 multiply. Maybe I can say like that. This is M1. Say this is M2. I have to care M2GH. Look at kinetic energy at this point. Just this object moved to 1.5 kilometer. Just assume now this one is comes to here. And this part is 1.5 kilometers. What's the height? What's the elevation? Of course, if all of them is h, this one is 1.5, this small part will be h minus 1.5. Okay. Now I can write all formula. I don't know kinetic energy, but there is also kinetic energy. Don't forget here, there is velocity. You can please look at here at Ford machine and this platform are quite similar each other because 2 objects connect to each other. So if this is this mass has v velocity, also this mass has same velocity. Just please be careful. I will write all kinetic energy coming from this one. So 1.2 m1 v square plus there is 1.m2 v square, and also there is small potential here. Just I want to continue below. M2G, what's my elevation? H1 minus 1.2. And don't forget work coming from friction. How can I write it? Fd. Which mass the friction applies to which mass? Of course, M1. So how can I write this F? This is Fs D. Okay. Sorry, maybe I need some space. Give me some space. Maybe I can write here. I know this one is Fs and D. What is the Fs? Fs always I can write here, and it's horizontal platform. If there isn't exerted force, and will be mg. Mg, and sorry, don't forget friction here. Sorry, I don't want to make friction. In some space, I will clean that some part. Oop. Sorry. From here. Okay. Some space, I will use that one. Okay, Fc min and mu k. There is horizontal platform here, and there isn't any F force like that. So just your N will be mg. So just you need to write mg, mu, k, and d. What's the d? Of course, d is 1 point. If this m2 fall down by 1.5, of course, there is a connection here. This part move by x, say x equal to 1.5. So say d. I don't want to make any confliction. D will be 1.5 meter. Okay. Just unit write that part. FC is M2. No, not M2. M1. G. And nu K multiply 1.5. Because the moment is 1.5. If you put all of them, M1 is 3 kilogram, 2 is 5 kilogram, and then G is 10. Finally, please don't forget mu K. Mu K is 0.4, is it? Am I right? Yes. Finally, you can find velocity, which is, give me a second. What's the question number? Where is my question? Sorry, where is it? Sorry, that's mistake. Third one. And velocity will be 3.77. Okay. Thank you. We can move other question.